Hi, everybody, and welcome back. So you understand some of the basics of how to write a function. Now let's talk about how to write functions well. That's going to be the point of this lesson. So we'd already talked a little bit about control flow. We've already talked about the components of a function, that functions, whenever you create a function, you always start with the name function. It's a reserved word. And then you've got arguments. So I'll go back and give you this example. So here's some arguments right here. And then there is an expression inside of the curly braces that often use arguments. Most of the time, the expression is going to use the arguments. And then here's the name of the function. Now we're going to get into best practices, and we're going to talk about function scoping, and then we'll be done with this lesson, I think. So here are some things. This is an assignment for you, even though it's not listed as an assignment. Um, go through some of the R Inferno, particularly related to things like for loops. Okay. Now, this assignment is going to be optional, and I'm going to explain who needs to do this assignment. If you have never seen R before, don't worry about this. Okay. Well, okay, let me clarify that. If you've never seen any computing languages before ever, don't worry about reading this material. If, however, you're coming to R either from someone who taught you R previously or from a language like Java or C++ or something else where you learned other programming practices and you're coming into R and you're trying to learn R, maybe you learn, even if you learn Python, although Python's pretty similar to R. If you learned code from someone else other than me, you need to go read through some of the material in this book. It will teach you why why it has the idiosyncrasies that it has, okay? Because if you come to R, writing functions in R like you would write them in Python, or actually Python is similar-ish enough where you can get away with some of that stuff. You still probably at least breeze through this R Inferno stuff. But if you're coming to R from having written C code or Java code or something else like that, then you really need to understand why R does things differently. Okay, because you would actually be making your code slower if you write R code like you would write C code or Java code. Okay, so if you're coming to R from another programming language, this looks normal to you. You say, okay, well, I want to add up, I want to add up all of so I've got a set of numbers. I want to take the log of all of those numbers and I want to add them all up. Then you say, okay, well, I'm going to initialize the sum to be 0, and then I'm going to write a for loop that says for the index and along the length from 1 to however long the vector x is, then I'm going to take the whatever this log sum, which starts at 0, and then I'm going to add it to the first element of x. And then I'm just going to keep doing this through this for loop until I'm done with all of the elements of x. Okay, this is a very, very standard thing to do in Java or in C or many, many other programming languages. This is an absolutely atrocious and horrific thing to do in R. The reason why is because R is vectorized, and it was written so that this entire chunk of code can be written as this. Okay, so go through, and this, again, I'm going to say this exercise is optional, as in, if you've never learned any other programming languages, you don't have to do it. If you have learned other programming languages, you need to read the R Inferno and understand why R does weird things, or R does different things than what you were expecting and what you learned in your other computer science classes. Okay. Now, talking about function best practices. When you are writing functions, I do not want you to see one function called clean the data that has 700, 800 lines and does everything from top to bottom. Dear God, if it breaks, how are you going to fix something like that? Okay. You just, all it sees, you just see an error down at the bottom. You're like, okay, well, I know that I have a problem somewhere between line 100 and line 700 of this function. Oh my goodness, that is just, that would be horrible. Okay. Don't do that. your functions for cleaning your data, which you should write functions to clean your data. You absolutely should. But they should do one thing, they should do only that thing, and they should do that thing well. Okay. So if you've got a part of your data that says, okay, well, I need to find the columns in my data set that are listed as character information because someone put like the word missing, MISSING, instead of NA. And so now all of the column is character information. So I need to clean up those columns. That can be its own function. Okay. And you just say, okay, this function is designed to check which columns are character information, but they should actually be numeric information. And so that could be one column, one function. And then you can have another function that says, once I've used this first function to check which columns should be numeric information instead of character information, then I'm going to use another function that is to fix the columns that are character information, but should be numeric information, okay? And then you've got another function that normalizes another set of columns, and then you've got all of these things. And so what you should do is you should make your functions honestly pretty small, okay? The reason that you should make your functions small is because they're so much easier to test and they're so much easier to document. And if one of them breaks, it's really easy to fix, okay? If you got this giant function and something breaks in it, you're gonna be sitting there for an hour, maybe more, maybe 5 hours, trying to figure out where this function is, how this function is breaking, and where it's going wrong. But if you've only got like 10 or 15 lines of code in this function, it's going to be relatively simple. Like, okay, I can probably get through, I can figure out where this function broke and hopefully fix it within like 15, 20 minutes. Okay. Now, this is not a law. Like, I'm not going to have you arrested if you don't do this, if you write your giant functions, because some people love doing that. It's stupid, but some people love doing it. However, I'm giving you this as advice from the many, many, many years of writing functions and packages in R that I have. One of the other things is if you submit packages to Bioconductor, Bioconductor literally has a check for the length of functions. And if I remember correctly, they put a threshold there for about like 50 lines, and they say that functions shouldn't be longer than 50 lines. And that's not like, again, it's not gospel. They're not going to reject your code if you have one function that's 55 lines instead of 50. But if the whole of your package is built up of these really, really, really long functions, they're probably going to come back to you and say, we're not going to accept this because it's too easy for this code to break. And when it breaks, it's going to be really, really challenging to troubleshoot and fix the bugs in these functions. You need to make your functions shorter and simpler. Okay. All right. The next thing, major functions should be saved with their documentation in their own script files. Okay. So a lot of times, if you're writing functions that are going to help you clean up your data, if you've got a function that does something really, really cool, create an R script dedicated just to that function and call it, like whatever, really cool function.r or something, whatever the file is. And then inside that file, you should have the documentation for that function and nothing else. And included in the documentation is an example. Okay. So you will have an example of that function. But the documentation, but that's actually included as one of the as part of the documentation. The examples for the functions are actually going to be the foundation for how you build the tests for that function. So if a function has good examples, then you can take those examples and turn them into unit tests, which we're not going to talk about so much in this semester. But if we do like an R for data science version, like second semester or something, or if you come work on your dissertation with me, and we end up building an R package, then we'll talk about unit tests a little bit more. Also, if you go and take some of the more advanced R classes at some other, either at this school or somewhere else, you should probably try to spend some time learning about unit tests and how to build a package. But it's a little bit out of the scope of this course. But it is good stuff. And I actually have that right here. Create a package. It's once you have most of this semester, getting from like learning R to creating an R package is honestly not as hard as it sounds. Once you're good in, like, once you've been through all of this material and you've got some experience in R, creating the package, you can sometimes do that with less than a week, even for your first package, just to learn how everything works and do it. But anyway, so if you create a cool function, then it should go in its own script. If you've got like kind of silly utility functions that you need, but they're really simple, like this, like we're just like, oh, give me the log sum of something. You can collect those really short, kind of silly functions into a single script called the utilities. And you can call it like utilities.r or something, but just make sure it has documentation for each function. And you can use like the 6 pound signs to give you sections in that script, so that you're organizing your utility functions. But I would say as soon as a function gets even longer than like 4 or 5 lines, it needs to be its own script. And it doesn't cost you anything. It's not like it's clogging up space on your computer or memory on your computer. These are flat text files. They're tiny. And we're talking about literal bytes of computer code. Like it does not cost you anything to organize your functions in a good way. And that's point number 3. Collect your utility functions into one file. Okay, that's all for now. Again, if you have never done any computer code before, you don't have to read the R Inferno because you're not trying to unlearn something about R and then relearn it. But if you're coming from any other programming languages, you need to go through this, at least breeze through the material. And if you're coming with a foundation of other programming languages, you'll be able to look at the section headers and be like, okay, I probably need to read about that or read that chapter or whatever. Okay, and next time we will talk about function scoping, and we'll talk about why the arguments of a function and how the expression inside of the function interacts with the arguments of that function. So I'll see you next time.